All right. So 54. Last time we learned a different way of factoring, right? The first way we did for factoring trinomials was the AC method, where we multiplied A and C. But this time we're doing the trial and error method, right? So the trial and error method was when your A was C. A was equal to 1. So we found the factors of C that add up to B, right? So the factors of C, right, that add up to B. Um, okay, so we know C here is 24. So what are the factors of 24 that add up to negative 10, right? So the factors of 24 that add up to negative 10. So if we list that out here, right, we have factors of 24 have to be both negative, right? Negative 1, negative 24, negative 2, negative 12, right? Negative 3, negative 8, negative 4, negative 6. So as you can see here, right, if you do negative 6 and negative 4, add up to negative 10. So those are our two factors. Once you pick the factors, you know that this will factor to x minus 4 and x minus 6. Any questions with that? If you have a question, please type in chat, or you could say it out loud. I will move on to number 55. Okay, so for 55, we have A is equal to 1, right? So we can move on, look at factors of C. So factors of 12 that add up to negative 7, right? So if factors of 12 have to be both negative, right? Yes, I am. Not as I just talked about it earlier. I don't know if you heard me. I said that last Friday my internet was down, so I used a different computer. And when I screen recorded it, it only recorded the screen without my voice. So I have to re-record the entire thing. Once I get to that, I'll upload that one. But anyway, this one I started recording, so we should be okay. So anyway, back to this. We have factors of C, right, which are 1, negative 1, negative 12, negative 2, negative 6, negative 3, negative 4. And we see that negative 3 plus negative 4 gives us negative 7. All right, so we know that this is just A minus 3 times A minus 4. Not too bad, right? Okay, let's see the next one. W squared plus 13. Oh no. Huh. Where did all the writing go? Let me see. Let me just redo. Okay, there we go. W squared plus 13W plus 40. Okay, why is it doing that? Alright, so again, A is 1 here, right? So we're good to go. Factors of 40 that add up to positive 13. So positive 40 that adds up to positive 13. So that means both our factors are positive, right? So I got 1 and 40, 2 and 20, 3 doesn't work, right? 4 times 10, right? We got 5 times 8. So we can see 5 plus 8 equals 13. Therefore, the factors are W plus 5 and W plus 8. And as always, you can double check your work to see if you did it correctly by foiling, right? If you distribute these, right, you should get W squared plus 13W plus 40. Okay, so let's see here. We have number 57. Okay, so for 57, A is 1, right? Therefore, where's my, there it is. Oh gosh, sorry. Okay, so A is 1. Factors of 64 that add up to 16, right? So let's see here. We got 1 and 64, 2 and 32, right? That clearly doesn't work. But then if you go on to 8 and 8, right? I'm going to skip some factors here. 8 and 8, right? You can see add up to 16. So therefore, this is x plus 8, x plus 8. Okay? And 58. Remember how we said if the leading coefficient is negative, you have to factor out a negative, right? So first things you want to do is to factor out this negative 1 out. So let's do that, and we get r squared minus 15r plus 36. Now that was an important step, because if you didn't do that, you would have gotten the wrong ABCs here, right? So A is now positive, B is negative 15, C is 36. So 36, factors of 36 that add up to negative 15, right? So we have 1 and 36 have to both be negative, and 2 and 18, both negative, negative 3 and negative 12, right? And as you can see, before even continuing on, that this is our solution, right? So what I'll do is I'll keep the negative out front here. Don't forget that's one of the factors. And then you have r minus 3, r minus 12 as our final solution. Okay, any questions so far? Okay, last homework problem was 62. Let me get there. All right, so with problem 62, you see that the GCF, right? First rule of factoring is to factor out a GCF if possible. So that means we're going to take this 2 out. Factor out the 2, we get x squared minus 2, x squared minus x minus 20, right? Now you have a is 1, right? B is negative 1. C is negative 20. So we have to find the factors of negative 20 that add up to negative 1, right? So if the C is negative, that means one of them is positive, the other is negative. But when B is negative, the larger factor is negative. Does that make sense? So that means this is negative 1, positive 1, negative 20, right? Positive 2, negative 10. 3 doesn't work, 4 works, right? Positive 4 and negative 5. So you see positive 4, negative 5 add up to negative 1. So that means our final answer is 2 times x plus 4 times x minus 5. Any questions regarding the homework problems from Friday? If not, I will post this on YouTube later today. Okay, we're going to move on with our new lesson. Today we're going to learn how to solve these factoring problems are now equations, right? So we're going to learn how to solve these quadratic equations through factoring. Okay, there are 3 ways to solve quadratic equations, but today, since we're on chapter 6, we'll be doing it by factoring. and then later on we'll learn the other methods. Okay, so first thing we want to talk about is something called the zero product principle, or the zero factor rule. Depends on which book you use. Now, the zero product principle says if a number A times a different number B is equal to 0, then A is equal to 0 or B is equal to 0, right? That's the only way you can multiply and have a product of 0, right? So basically, you can also have the case where A is equal to B is equal to C. Now, let's look at our first example here. We have x squared minus 3x minus 18. So that's kind of like what we were doing so far, right? Factoring. So let's factor that. So we have our A is equal to 1, right? We have our B is equal to negative 3, and our C is equal to negative 18. So now that our A is 1, we can just find the factors of C that add up to B. In order to do that, we have to write them out. So I hope you're getting the hang of this, right? When your C is negative and your B is negative, the larger factor is negative. So positive 1 times negative 18, positive 2 times negative 9, positive 3 times negative 6, right? And that's how we came up with 3 and negative 6 equals negative 3. So now we can factor. We have x plus 3 times x minus 6 is equal to 0, right? Because that's what the equation says. Our original equation right here. So we just factored it to that, right? So now using our zero product principle, we're going to realize, okay, so we have some number x plus 3 times another number x minus 6 is equal to 0. That must mean x plus 3, either x plus 3 is equal to 0, or the other number x minus 6 is equal to 0. So we'll do both cases here. We're going to have to write it out x plus 3 equals 0 and solve for x. So what do? We subtract 3, right? If we subtract 3 on both sides, we have x is equal to negative 3, right? And then for the other one, we have x minus 6 equals 0. So what do? We add 6 to both sides. Therefore, we get x is equal to positive 6. So our final solution is x equals negative 3 or x equals positive 6. And that is how you solve a quadratic equation through factoring. So now I want you to try the next problem on your own. Same method, right? What we've been doing here is we have to set it equal to 0. I should mention that first, right? If it's not equal to 0, that's the first thing we need to do. But this one it is. So we can factor the left-hand side of the equation here. X squared minus 9x plus 20. So give it a try, and then we will go over it. Okay, so the first problem here, we look for the GCF, right? GCF here is x, right? They're quadratic with two terms, or actually any factoring problem. That's what you first look at. So this, we can look at it as x times x plus 8 equals 0. That's right. Then we said each factor equal to 0, right? We have x is equal to 0, or we have our x plus 8 equals 0. So the first one is done. Second one, we should subtract our 8, and we get x equals negative 8. So we have two solutions, right? We can write it as x equals 0, comma, negative 8. All right. With the second problem, we have a difference of squares, right? This is the same thing as saying x squared minus 4 squared, right, equals 0. So if we were to factor that, we get x plus 4 times x minus 4 equals 0. Then you can set each factor equal to 0. So we have x plus 4 equals 0, or x minus 4 equals 0, right? So we can subtract 4 here. We get x equals negative 4. and add 4 to the second one, and we get positive 4. So our solutions are x equals negative 4 or positive 4. Any questions? All right, moving on. So now we see an example where we solve the equation by factoring. However, what's the issue here? We have 2x squared minus x equals 3, right? It's not set equal to 0. So we can't solve a quadratic unless it's set equal to 0. So that's what we do first, okay? So we're going to move that 3 over to the left-hand side. And the way we do that is by subtracting 3 to both sides, right? So we have to subtract 3 to both sides, and then we end up with 2x squared minus x minus 3 equals 0. Okay, now that it's equal to 0, we can factor. So now you'll see that the a is equal to 2, right? So we can't, we haven't really practiced too many problems with where the trial and error method, right? Where a is equal to a larger number than 1. So if you like, you can go back to the AC method of factoring, or if you want to keep improving, you can try it the way we learned it on Friday. Okay, so I'll show you both methods while we're doing this because you know, it takes a lot of practice anyway. So the first method, right, you're going to see that um, the a is equal to 2. So the only way we can get that is if we have a 2x as our first term and an x for our second term, just like that, right? And let me see here. And then once you get to this point, you want to look at your c. Your c is negative 3. So there are only two ways to place the negative 3, right? Your c is negative 3 and your b is negative 1, right? So either I'm going to have the 1 position here, right? And the 3 here. I'm not going to write the signs just yet. Or you could put the 3 here and the 1 here. Do you remember that? We did problems like this last week, right? So let me write down both, right? Kind of do it as a practice run here. So if I have the outer and the inner for each of these, right? The outer here is 6x and inner is x, right? Now one of them's got to be negative, but either way, will it give you a negative 1, even if it's a 6x and a 1x? No, right? If you subtract, you're going to get a 5x, either positive or negative. So it's not going to be that one. So I look at the second one. The outer is 2x, inner is 3x. So as you can see here, right, what would cause this to be a negative 1x? If you're 3, right, your 3x is negative, right? So that means this 3 has to be a negative and the 1 is positive. So that's the trial and error method of factoring. That's how we got 2x minus 3 and x plus 1 as our two factors. Okay, so again, that's from last Friday. That'll take a lot of practice. Or you can do the AC method, which I'll do right over here below. Okay, so I have the AC method is A equals 2, B equals negative 1, C is equal to negative 3. Remember, we have to look at it once it's set equal to 0, okay? Otherwise, you can't solve the factoring problem correctly. Now, A times C is equal to negative 6. I have to find factors of negative 6 that add up to negative 3. So that means the larger factor is negative, right? So 1 times negative 6, 2 times negative 3, right? I'm sorry. Now you see that 2 and the negative 3 add up to negative 1, right? So we can now replace the middle term with 2x and negative 3x, right? So this is 2x, negative 3x. So let's go ahead and do that. We have 2x squared plus 2x minus 3x minus 3 equals 0. And if you recall, we have a polynomial of 4 terms, so then we see this as a factor by grouping problem, right? So the GCF of the first group is 2x. So we factor 2x out, and we have x plus 1, right? This is from last Wednesday. Then we move on to the second pair, or the second group. The leading coefficient is negative, so we factor out a negative along with the 3, right? And we have x plus 1 and then equals 0 because it's an equation. And we can see there's a common binomial factor of x plus 1, right? X plus 1, and the other factor is what's remaining, 2x minus 3. And we still have equals 0. See that? It's the same solutions, factors as the other way, right? And it should be, right? Now you set each factor equal to 0, right? And you solve for x. So the first factor, you subtract 1, you get x is equal to negative 1. And in the second one, right, we have to add 3. So we have 2x is equal to 3. Divide by 2, right? So x is equal to 3 over 2. So our solutions are x equals negative 1 or 3 over 2 as our final answer. Any questions? Okay, so the AC method would require us to do A times C. So that's 3 times negative 2 equals negative 6. And B is equal to negative 5. Right? So one of the factors have to be negative. As you can see, the larger factor, right? Positive 1, negative 6 gives us negative 5. So what I'll do is replace the middle term with 1x minus 6x, right? So this becomes 3x squared plus 1x minus 6x, right? Minus 2 equals 0. Now we can factor by grouping. So in the first group we have x and we have 3x plus 1. In the second group, it's a negative leading term, right? Leading coefficient is negative. So we have to factor out the GCF of a negative 2. And we have 3x plus 1. And then the equals 0. So look, inside the parentheses, we have the same, it's a common binomial factor, right? So we got 3x plus 1. And the remaining factor is x minus 2 equals 0. So we can set each factor equal to 0. I'll continue it over here. 3x plus 1 equals 0, or x minus 2 equals 0. So this one, we subtract 1. We get 3x is equal to negative 1. And then divide by 3, and you get negative 1/3. For the second one, we add 2, so we get x is equal to positive 2. So we have two solutions, right? X is equal to negative 1/3, comma 2, right? Or, any questions? What's wrong with yours? Glitching? Can't see the screen? So we're going to solve x squared minus 6x plus 9. So you're going to notice when we factor this, right, our a is 1. Right? When a is 1, those are the best or easiest trinomial factoring problems. So I look at my b is negative 6, c is 9. So c is positive, b is negative. That means both the factors of 9 have to be negative, right? So for 9, I got negative 1 times negative 9 adds up to negative 10. That's not it. Then I move on to negative 3 times negative 3. That adds up to negative 6. So we found our two factors. So now we can factor it as x minus 3 times x minus 3 equals 0. Right? So it's the same factor, right? This is called a double root or a repeated root. So we have x minus 3 equals 0, x minus 3 equals 0, and x equals positive 3 here, or x equals positive 3 there, right? So in the case where it's the same solution, you could just write it once. And that's the final answer. Okay, so later on we're going to see that what the graphs of these quadratic equations look like, and how the double root or the repeated root makes the graph look a certain way. So hopefully you can do the next problem easily on your own. X squared plus 6x plus 9 equals 0. Okay, so A is 1, B is 6, C is positive 9, right? So as you can see, positive 1 times positive 9. If we add it up, you get 10. I don't know if you can see that color here. Let me change. So positive 1 and positive 9 give us a sum of positive 10, right? And 3 plus 3 equals 9. So clearly it's positive 3 for both, right? So you got x squared, oh, why did I do that? X plus 3 times x plus 3 equals 0. Then you set each factor equal to 0. X plus 3 equals 0. X plus 3 equals 0. And you see that's a repeated root. Subtract 3 on both sides. You get x equals negative 3, right? X equals negative 3. Same solution. So final answer is just x equals negative 3. Any questions? All right. Let's move on. We have 3x squared minus 3x minus 60 equals 0. So again, first thing you want to do is set it equal to 0, which it already is. Then we want to see if there's a GCF, right? Every factoring problem, see if there's a GCF. There is, right? It's actually a 3. So GCF equals 3. So you factor that out, and I'll write it here. You get x squared minus x minus 20 equals 0. So now this is where it's different from our previous problem, our previous factoring problems. This is now an equation that we're solving for x, right? So do you recall when we're solving a problem like this up here, 2x is equal to 4. We want to solve for 2, right? We want to solve for x, excuse me, right? So that means we divide both sides by 2. That's why x is equal to 4 divided by 2 is 2. Right? So if you recall that, you're going to see that this is the same case. 3 times the quantity x squared minus x minus 20. Since we're trying to solve for x, we can divide both sides by this number, this constant of 3. Okay, you can't divide by a variable, but you can divide by numbers, right? So what are we left with? The 3's cancel out to a 1. And you have just x squared minus x minus 20 is equal to 0 divided by 3 is still 0, right? Let me make another note here, right? 0 divided by 3 equals 0. 3 divided by 0, does anyone remember what that is? If you divide by 0, you should get undefined, right? Not a real number. All right, so now we can continue on. X squared minus x minus 20. So a is 1, b is negative 1, c is negative 20. So the factors of negative 20, right, are positive 1 times negative 20, positive 2 times negative 10, positive 4 times negative 5 gives us negative 1, right? So that becomes x plus 4 times x minus 5 is equal to 0. And then we can set each factor using the zero principal rule, right? Or zero factor rule. So x plus 4 equals 0, or x minus 5 equals 0. Subtract 4 here, you get x is negative 4, or x is equal to positive 5. So you could either write it like that, or you can write it as x equals negative 4 or 5. All right, so first thing, we know that we want to check it's equal to 0, so we're good to go. And then we see that there is a GCF, right, of 2. So if I factor out a GCF of 2, I get 2 times x squared minus 5x minus 24 is equal to 0, right? Since this is an equation, I can divide both sides by 2, right? And that's still equal to 0. So I'm left with x squared minus 5x minus 24 equals 0. Finally, our a is equal to 1, so this is one of our easier factoring problems, right? I just have to look at the factors of c that add up to negative 5b, right? So we know that the larger factor has to be negative, right? So I have positive 1, negative 24, right? That's not it. We got positive 2, oh, that's not it. Positive 2 and negative 12, right? Positive 4, oh, I'm sorry, I should do 3. Positive 3, negative 8, right? And positive 4, negative 6. And you can see from here, this one is equal to negative 5. So this factors into, the two factors are x plus 3, x minus 8 is equal to 0, right? Therefore, we set each factor equal to 0 using the zero principal rule or the zero factor rule, right? So we have x is equal to negative 3 or x is equal to positive 8. Two solutions. Any questions? All right. So if you want to refer back to this, you can. These are the steps of factoring, right? First thing we want to do is set it equal to 0 by adding or subtracting the necessary steps, right? Look for the GCF that you want to factor. If not, right, then you factor the quadratic, set each factor equal to 0, and then solve for x, right? Okay, so that's our quadratic equation where it's ax squared plus bx plus c equals 0, and a is not equal to 0. So one thing to note here, whenever we solve for x here, right, later on we're going to see that those x's are actually zeros of the function, or 0, which are x-intercepts on the graph. Okay, so we will explore that later on in the chapter 8. For now, let's continue on, do more factoring problems. We have over here, in function notation, right? If you recall, well, probably too far back to remember, function notation, right? This is read f of x, right? I'll just write it here in case you forgot. F of x is function notation is equal to x squared minus x minus 2. So we want to find the zeros of the function, meaning where is f of x equal to 0? Right? So the first thing we want to do is just take f, which is x squared minus x minus 2, and set it equal to 0. Right here, set it equal to 0, right? And factor to solve for x. So we find the factors of negative 2 that add up to negative 1. So that means negative 1, positive 1, negative 2 add up to negative 1. So we can do x plus 1 times x minus 2 is equal to 0. Then you set each factor equal to 0 and solve for x. So this is the same thing that we've been doing today, except it's just in function notation, so we have to actually write it out. Write out, set it equal to 0, and then write out. So let's try this next one together, and then I'll give you a few problems we can do on our own. So find the zeros of f of x. So f of x equals 2x squared minus x minus 3. So first thing is set the function equal to 0. Next, I want to look for the GCF, right? Just check, is there a GCF? There is none. So we have to factor. Now the problem is our a is greater than 1. So we can do the AC method of factoring or the trial and error method, right? So I'll just show the AC method, and if you want to know the trial and error method, I'll show you that as well. So we have a times c is 2 times -3 equals -6, and b is equal to -1, right? So if b is equal to -1, that means the larger factor is negative. So I have +1, -6, +2, -3, right? So this will give us -1. I replace the middle term with those, right? So I have 2x squared plus 2x minus 3x minus 3 equals 0. So now we can continue by grouping, right? So the first two is the GCF is 2x. So we factor out 2x, and we have x plus 1. In that second group, you see there's a negative leading term. So we factor out the GCF of a -3, and we have x plus 1 equals 0. So now the common binomial factor is x plus 1. I'm going to write it up here on the right side. X plus 1, and the other factor is 2x minus 3 is equal to 0. Now we're almost there. We said each factor equal to 0 using the 0 principal rule or 0 factor rule. And this is what we get. So let's solve for x here. First one's easy, right? Subtract 1, so x is equal to -1. The second one, we add 3, so we get 2x is equal to 3. X is equal to 3 over 2. So our final answer should be x equals -1 or 3 over 2. Okay, any questions? Let's give these a try. Okay, so we have number 11. We first need to set it equal to 0, right? So I have x squared is positive on the left-hand side, so I'm going to move these to the left-hand side. So I have x squared, subtract 5x, subtract 84 is equal to 0. All right, so thing about 84 is let's write out the factors of -84. So that means b is negative, so I have the larger factor is negative, right? So I have +1, 84, +2, that's 42. We have +3, and that is 28, right? I forgot to put the negative signs here. And then we have +4, and this is what, -21. So that's not it. How about 6, right? 5 wouldn't work. 6. So if I did +6, this is -14. So as you can see, we're going to have to go one more, right? Let's see here. -5. 4. Oh yeah, 7 works, right? So this is +7 and -12. Very good. So this adds up to our -5. And we can rewrite this problem, right, as a factor of x plus 7 and x minus 12 equals 0. Then we set each factor equal to 0 and solve for x. So subtract 7 here, -7 and 12. So we could write our answer like that. Number 13. It's already set equal to 0. So the GCF is what I'm going to look at next, is x. So we have x and x minus 8 equals 0. So we can set each factor equal to 0, x equals 0, or x minus 8 equals 0. So first one is done. We add 8 for the second one to solve for x. So our solutions are x equals 0 or 8. And the last one, x squared equals 5x. So first we need to set this equal to 0, right? So we subtract 5x on both sides. We get x squared minus 5x equals 0. And the GCF here is x. So we have x times x minus 5 equals 0. So set each factor equal to 0. And we have x equals 0 or 5. That wasn't too bad, was it? All right. And then the last problem that we'll do today, unless you want to practice more of these. Let's try number 29. So number 29. I'll give you a few minutes. Okay, so let's set this equal to 0, and we get 6x squared. We're going to subtract the 7x, add the 2 to both sides, and this is now equal to 0. There's no GCF here, right? So now we just have to do A times C. So AC is 6 times 2 is 12, and B is equal to negative 7. So that means both my factors have to be negative, right? So negative 1, negative 12, negative 2, negative 6, negative 3, negative 4 gives us negative 7. So now we can replace the middle term with negative 3x and negative 4x. So now this is 6x squared minus 3x minus 4x plus 2 equals 0. We could factor by grouping. The first group, the GCF is 3x. And the other factor is 2x minus 1. And in the second group, the leading coefficient is negative, so we should factor out a negative 2 as our GCF. And we have 2x minus 1, and the right side is equal to 0. Now we have a common binomial factor, so we factor that 2x minus 1, and the other factor is 3x minus 2 is equal to 0. So lastly, we can set each factor equal to 0 and solve for x. So on the left side, we have 2x, we add the 1. So 2x equals 1, divide by 2, we have 1/2. And the second factor, we have to add 2. So 3x is equal to 2. Divide by 3, and we have x is equal to 2 over 3. So here are our two solutions. Any questions?